It's still a half day on Wednesday and Thursday, right?
Ladies and gentlemen, let's begin here. On this practice test, the first part, they want you to analyze these polynomial functions, and they want you to describe the end behavior, determine whether it represents an odd or an even degree polynomial function, and also state the number of real zeros that it has. So let's begin with describing the end behavior. Now, this is important because the way we did it in class is they write it backwards. Their notation's backwards, but it's still the same thing, all right? So if we look at option A, it says the end behavior of the graph is f as f of x approaches positive infinity. So what does this mean as f of x? They're not talking about x. They're talking about f of x. What does that mean? The y's, right? The answers, the y's. Okay, as the y values, now the y values go up and down. So as the y values go up, as the x values go to the right. Okay, so does this y value go up as the x value goes to the right? Yeah. Yes, right? This f of x goes up. The y values also go up as the x goes to the negative infinity, which means to the left. Goes up as it goes to the left. Does that make sense? Yeah. All right. So A satisfies this when it talks about end behavior. Now the question is this first one, is it an even degree polynomial function? Yes, even degree polynomial functions are going to have end behavior either up here or down here. Right? There's two arrows going up or two arrows going down because the number 2 is even. Is this guy an even degree? No, because it only has one arrow up and one arrow down. 1 is an odd number. Is this one an even degree? No, it's odd because it has one arrow up and one arrow down. The only way it's an even degree is if it has both arrows up or both arrows down, as this one has both arrows up. So this is an even degree polynomial. So I guess even before doing end behavior, if you have a multiple choice question, you could jump to the more easier questions to answer, so you could start eliminating them, right? So this one's definitely an even degree polynomial. It had the correct end behavior that we wanted, and the function has 4 real zeros. Does this have 4 real zeros? Yes. Yes, it does. 4 real answers, 4 real roots, 4 real x-intercepts. So option A is for number 1. Okay. Let's look at option B. It says the end behavior, the graph, this says that the graph goes down as you look where? To the left or to the right? To the left. Does this one go down as you look to the left? Yes, it does. The y values go up as you look where? To the right. Does this go up as you look to the right? Yes. So far so great. It's an even degree polynomial function. Is this an even degree polynomial function? No. Unfortunately, that is not. Oh wait, you know what? I shouldn't scratch it out because maybe this other one works for it. Wait a minute, is this one an even degree polynomial function? Okay, so I could definitely scratch out B. Okay. C, the end behavior, the y values go down as the x values go where? To the left. Okay, so this does go down as you go to the left. That's good. The y values go up as x goes to the left or right? To the right. So it does go up as you go to the right. So this so far so good. It's an odd degree polynomial function. Yes. Function has 3 real zeros. No, it doesn't. It has 1, 2, 3, 4, 5. Hey, wait a minute. This one has 3 real zeros, and it has the same end behavior. So we have the answer right there, right? So this one is for 3. Okay, so 1 was A, 3 was C, and we still need to look for 2. Well, let's just look through the answers quickly. It says the end behavior, wait a minute, is it even? Is this one even? No, so D says that it's even. We could scratch that out because it's definitely not even. What else? It's odd. Okay, that works. Does the function have 4 real zeros? That's easy to answer. 1, 2, 3, 4, 5. So that can't be it because E says it has 4 real zeros, and we know that it has 5 real zeros. So what's our answer for this middle one? F. None of these multiple choice are correct. F. You guys got it?
Yep.
Same exact 3 questions, not exact, but similar, right? I'm going to put different graphs up there. Same exact format will be on the test tomorrow. All right. This, okay, it will be multiple choice, okay? I want to kind of get you ready for the final by giving it to you in the final format. As a matter of fact, final format's even easier because it only has 4 options. On my tests, I have 5 options, right? So even though it's multiple choice, you need to show all your work in the area provided below. No work, no credit. And it has to be correct work. It can't just be a bunch of scribbles, right? So on number 4, they want us to factor. And what kind of factoring are we going to do on number 4 right there? Is there a GCF? No. Sum of 2 cubes. Sum of 2 cubes. In case you forgot, if you have something cubed plus something cubed, you're going to have a binomial times a trinomial. The binomial will be exactly the same, a plus b. The trinomial is a squared. If the binomial had a plus, what's this middle term going to be? Minus ab plus b squared. I hope you remember that sum of 2 cubes formula. Now, the idea is, or the trick is, to identify what your a value is and what your b value is. So what could I plug in here that when I multiply it with itself 3 times, I'll get 64x to the third? For x, absolutely. Okay, and what could I plug in here that'll give me 125y to the third? 5y. So we have clearly identified the a value and the b value, and now we will be able to write it as a binomial times a trinomial, right? So what's the binomial going to be? The same exact binomial that we have here without the cubes. So you have 4x plus 5y. But you write that down, 4x plus 5y. And then over here, it'd be a good idea to plug it in with parentheses so you don't make mistakes. So what would a squared be? That's going to be 4x squared in parentheses. And then plus, actually, no, I'm sorry, minus ab. And we know that a is 4x and b is 5y. And last but not least, plus b squared. And b is 5y. So our final trinomial, once you simplify it, will be 16x squared minus 20xy plus 25y squared. And of course, we have this binomial in front, the 4x plus 5y. So the multiple choice on the test tomorrow, just like right here, I'm not going to give you the whole thing. I'm only going to give you one of the factors. So which one is the correct factor? D is the correct factor. Okay. It just says which of the following are factors. You might have 2 of them, you might have 1, or you might circle none of these because none of them are correct. Here's another one, difference of 2 cubes. So difference of 2 cubes, it's the same idea. Should we write down the formula? Okay, so difference of 2 cubes starts out something cubed minus something cubed is going to be a binomial times a trinomial. The binomial will be exactly the same, a minus b without the cubes. The trinomial is a squared. If your beginning binomial was minus, then the middle term will be plus ab together, multiplied together, and then plus b squared. So let's identify what our a value is and what our b value is. Wait, I put plus, it should have been a minus, I'm sorry. Same difference, it's just the sign changes. Okay, so what belongs in here that would give us a 27x to the third? 3x. And what could we plug in here that'll give us 8 when we cube it? 2. So this one's a little more easy. What's our first binomial going to be? 3x minus 2. If the binomial, the first binomial will always be the same exact thing without the cubes. So it had a minus, it's going to have a minus. Now the trinomial is where it gets a little more interesting. Do you guys want to try to do this in our heads instead of doing it in parentheses? Okay, what would a in parentheses, try to think of it in parentheses in your head. A in parentheses squared. So you'd have 3x in parentheses squared. What's 3x times 3x? 9x squared. How about a times b? What is 3x times 2? 6x, right? 6x. So let's put plus 6x. And last but not least, b in parentheses squared. B in parentheses squared. What is 2 in parentheses squared? 4. So there's our answer. Which one's the correct multiple choice answer? None of these in this case. Number 6. Any ideas on how to do that? We could do synthetic division. That's one option. But there's even a quicker way if you know the difference of 2 cubes formula off the top of your head. You do have a cube and a cube, perfect cube term. This 4 cubed gives you 64. So if you wanted to, you could rewrite it as a difference of 2 cubes because this becomes an x, this becomes a 4, and notice that the first binomial you're going to have is going to be x minus 4 when you do the difference of 2 cubes formula, and that's the same binomial you have right here. So let me show you. I'm going to rewrite this with the difference of 2 cubes formula. It will be a binomial times a trinomial, right? The binomial will be what? X minus 4. The trinomial will be what? Let's do a squared. Think of it, a in parentheses squared. What does that become? X squared, right? And then you have, if it was a minus, this is a plus. We're going to put a plus. A times b, x times 4. What's x times 4? 4x. Last but not least, b squared, in parentheses, b squared. What's 4 squared? 16. So we really have this being this, and we're going to divide it by the binomial x minus 4. So if you just put a division bar like this, and you divide it by the binomial x minus 4, check it out. You have the identical binomial here, identical binomial there. So you will be able to just cancel them out, and there's your answer. Okay? Could you have done this with synthetic division? Absolutely. The synthetic division setup would be this. You'd have to put a what inside the box? Positive 4 in the box. Tell me the coefficients of this cubic binomial. 1, 0, 0, negative 64. Okay, the 1 comes down. 4 times 1 is 4. 4 plus 0 is 4. 4 times 4 is 16. 0 plus 16 is 16. 4 times 16 is 64. Remainder 0. This would be your answer right here. All you got to do is write it as your depressed polynomial. X squared plus 4x plus 16. Same thing. So it's totally up to you, all right? You have the option whether you want to do synthetic division or rewrite it with difference of 2 cubes formula. There's a question almost exactly like this on the final exam. So same deal. It's up to you, your option. Okay? Let's move on to number 7. This is just some basic factoring. What could we do here? The first type of factoring you should always try is the first type of factoring that you learned, which is pulling out a GCF. Let's take out that 2. What would we have left? We'd have a 3a squared plus 1a minus 4. And now on the inside, there's nothing else to do, but we could do something. It's a quadratic trinomial. Unfortunately, the a value is 3, which means we've got to go through that long process. The first process is a times c, which will give us negative 12. Then after that, you think, what times what is negative 12? That combines together to give you the middle value, which is positive 1. So let's make a list. How could I get negative 12? It could be negative 1 times 12, negative 2 times 6, negative 3 times 4, and that's about it. Which pair of numbers combines together to give us a middle value b, which is 1? Negative 3 and 4. I don't need to do any sign changes. The third step is to do your factored form format, but it's kind of weird because we're going to put the ax term in the front and the ax term in the front, right? What is the ax term? And we're working with the blue one, not with the original. Working with the blue one. So what's the ax term that belongs right here? 3a, but in this case 3a instead of 3x. And then what belongs in these blank spots right here? These numbers from step 2, the positive 4 and the negative 3, right? So let's put that negative 3 right there and the positive 4 right there. And the fourth magical step is to reduce whatever binomial you can, or both binomials, by whatever GCF they have. Just magically divide them. So the first binomial will be what? A minus 1, because you divide by 3 on both terms. And the second binomial, there's nothing to divide by, so you leave it the same. So they want us to completely factor. Let's not forget about this 2 that we pulled out originally. You need to put that 2 right there in the front. And ladies and gentlemen, there's your answer. 2 out in the front, binomial a minus 1, binomial 3a plus 4. What kind of factoring are we going to use on this one? Grouping, right? We have 4 terms. You first think GCF. You're like, oh, I'll pull out an x. Wait a minute, there's no x there. Oh, I'll pull out a 3. Wait a minute, there's no 3's over here. Then you realize, hey, there's something in common here, something in common over there. So let's separate them into 2 groups. You have x squared minus xy space 3x minus 3y. In the first group, what could we pull out? X. What would be left over on the inside?
X minus y.
X minus y. Okay, in the second group, what could we pull out?
3.
Positive 3. What would be left over on the inside? X minus y. So luckily we have a common binomial in the first group and the second group. We're going to take this x minus y and this x minus y and pull them out into the front. So we will have x minus y, put some exaggerated parentheses. What happens? This x comes down and the 3 comes down. So both of those come down and we're done. X plus 3. Final answer, x minus y, x plus 3. These questions come out on the final exam as well, guys. Let's jump to the back side. On the back side, given a polynomial and one of its factors, find the remaining factors of the polynomial, then select the correct multiple choice answer of one of those factors. All right, so they tell us that this binomial is a factor of this guy. So what should I do? Synthetic substitution, what am I going to plug in? Actually, because it's a binomial, this is a factor of it, because it's a binomial, you technically have to set it equal to 0 to know what your x value really is that you're going to substitute, right? So what am I actually plugging in? Positive 3. Let's do the coefficients. We have a 1, a negative 1, a negative 5, and a negative 3. As you come down, you add 1 plus 0 is 1. As you go up, you multiply. 3 times 1 is 3. As you go down, you combine, you add. Negative 1 plus 3, what is that? 2. As you go up, you multiply. 3 times 2, 6. As you go down, you combine. Negative 5 plus 6, 1. As you go up, you multiply. 3 times 1, 3. As you go down, you combine. 0. Now, this does not surprise me because they told us that this guy's a factor. We knew that this answer works. If it's a factor and you divide this by your factor, it should be 0. Just like if you divide 12 by 4. 4 is a factor of 12. 12 divided by 4, you're not going to have a remainder. The remainder will be 0. So this definitely does not surprise me. But we did this to get a depressed polynomial. And whenever you get to a quadratic equation, you might as well write it. X squared plus 2x plus 1 equals 0. Set it equal to 0 and then solve it. And this one is factorable. What times what is 1 that if you combine together is 2. Positive 1 times positive 1 is 1, and if you add them together it does give you 2. So when you split them, wait, what do they want us to do? Oh, they want us to write it in factored form. They don't want the answers, right? So I'm not going to split them. Those are the factors. So what's the answer to number 9? D. Boom. What do I do here? I'm going to plug in -1 because they tell us this is a factor, which means that if I were to set it equal to 0, my x value would be -1. So there's an answer. It's a solution. Let's do the coefficients. 1, 4, -7, -10. The 1 comes down. 1 plus 0 is 1. Multiplying -1 times 1 is -1. Coming down, 4 plus -1, that's 3. Thank you. Multiplying -1 times 3, -3. Going down, combining -7 plus -3, -10. Going up, multiplying -1 times -10, +10. Remainder is 0. No surprise, we already knew that. But the reason why we did this is to get the depressed polynomial. Once again, we have x squared plus 3x minus 10. Set it equal to 0 and solve. Wait a minute. Not solve, but factor. I keep saying set it equal to 0 like if I'm trying to find the answers. They don't even want us to find the answers here. They want us to just find the other factors. So you don't even have to worry about setting it equal to 0. If they told us solve, then we'd set it equal to 0, factor, split, and solve. Or use a quadratic formula. Right here, they just want us to factor. So what times what gives you -10 that if you combine together is +3? -2 and +5. Thank you. So which are the correct answers on number 10?
C and D. Wait, oh, no. Sorry. B. No. C. No. Wait.
Just B? It's just D. Just D.
Oh, yeah.
X minus 2.
C. Sorry.
There's no x plus 5 up here. If that were a plus, I'd circle that one also.
Yeah.
Right? Cool. Last two. I wish it was the last two. We have a lot more. Find all the roots of the following g of x function. So, guys, let me tell you, we're supposed to kind of use the rational root theorem, right? And you think of all the possible answers based off of the multiples of c over the multiples of a. So how could you get 8 and you put them over the multiples of 1, which is just 1? So you could get a list. Your list will be 1 because 1 times 8 is 8, 2 because 2 times 4 is 8, 4 because 4 times 2 is 8, and 8 because 8 times 1 is 8, right? That's your list. And your list, your notes said that it could be a plus or minus p over r. So it could be +1 or -1. Could be +2 or -2. Could be +4 or -4 or -8. So we're just going to start guessing. Pick one, plug it in with synthetic substitution, and see if it works. See if your remainder is 0. Now the deal is this. Look at your multiple choice answers. Which number do you see repeated in most of those answers? 1. Oh. Actually, there's no 1 right here. There's no 1 right there. There's no 1 right there. There's only 1 on this one. -1. So I see a bunch of -1s everywhere. So I know, I'm hoping that -1 will work. Okay, so I'm going to test -1, see if it works. I'll do the coefficients. 1, 4, -3, -14, -18. Oh, -8, I'm sorry, thank you. As you go down, you combine. 1 plus nothing is 1. As you go up, you multiply. -1 times 1 is -1. As you go down, you combine. 4, take away 1 is 3. As you go up, you multiply. -1 times 3 is -3. As you go down, you combine. -3 and -3 is -6. As you go up, you multiply. Negative times negative is a +6. As you go down, you combine. -14 and 6. What do we get? -8. And multiply. -1 times -8, you get the +8. And luckily, The remainder is 0. So we know that x equals negative 1. Okay. So we have one answer. How many possible answers could we have here? Total of 4, right? So let's continue to plug in other values. So what do you guys want to guess at? Both of these have negative 1s. They both also have 2s, right? And they both have negative 4. So what do you want to try, 2 or negative 4? So yeah, this is the strategy when you're taking a multiple choice test. Look at your answers and see what repeats. And you'll be able to get there faster. So let's try 2. And we could go with the depressed polynomial coefficients. So instead of going back to the original 1, 4, negative 3, negative 14, negative 8, we'll do 1, 3, negative 6, negative 8. It's shorter, it's quicker, it's nicer. 1, 3, negative 6, negative 8. As you go down, you combine 1 plus nothing is 1. As you go up, you multiply 2 times 1 is 2. As you go down, you combine 3 and 2 is 5. As you go up, you multiply 2 times 5 is 10. As you go down, you combine negative 6 and 10 is 4. As you go up, you multiply 2 times 4 is 8. Luckily, we get 0, so we know that 2 is also an answer. So far, we have negative 1 as an answer, 2 as an answer. Now, should I keep on plugging in numbers? I would just use the quadratic equation that you have down here, especially because, I mean, I guess you could plug in negative 4. That won't be that difficult to do. If it works. Negative 4 works? Okay, so you'd have the, oh wait, it could be none of these, right? Nah, if the negative 4 works, then your answer is B. But what you're supposed to do once you get to a quadratic is write it as a quadratic equation. Check it out. X squared plus 5x plus 4. And since they want the answers, you're going to set it equal to 0. You're going to factor, split, and solve, or use the quadratic formula. What times what is 4 that if you combine together is 5? Positive 1 times positive 4. So when you split them, x plus 1 equals 0, x plus 4 equals 0. You're going to get two answers, x equals negative 1 and x equals negative 4. So you actually have two negative 1s, a negative 1 and a negative 1. You also have a positive 2 and a negative 2. No, negative 4, sorry. So there you go. So B is the correct answer, which you guys already knew. So we're going to do the same for this guy. Oh, I'm sorry. Okay, number 12. Based on the answers you see, what should we test? Negative 2 sounds good, right? Let's try it. Negative 2. We are going to have a pretty long list if we just didn't have multiple choice answers, right? You'd have 1, 2, 4, 5, 10, 20. That's a lot of numbers. And then all those numbers negative. So you'd be testing a lot. But based on these answers, 2, negative 2, negative 2, negative 2, it'd be smart to try negative 2. Let's do the coefficients. And remember, go from highest degree all the way to the constant. You have to represent every term. What numbers am I going to put? 1 for the x to the third. 0 for the x squared. 6 for the x. And 20 for the constant. So as you go down, 1 plus nothing is 1. Negative 2 times 1 is negative 2. 0, take away 2 is negative 2. Negative 2 times negative 2 is positive 4. 6 plus 4 is 10. Negative 2 times 10 is negative 20. We guessed right. That was a well-educated guess because we saw that negative 2 pop out so many times. That's why we tested it, and it works. Should I test another one? No, because all these other ones are imaginary. See what I'm saying? So at this point, I am at a quadratic. 10 is the C value, negative 2 is the B value, 1 is the A value. Let me rewrite it just so you could see it. 1x squared minus 2x plus 10. And of course, I'm going to set this equal to 0 because I want the answers. So I'm going to use a quadratic formula to solve this. And of course, when you use that quadratic formula, you need to use parentheses so you don't make mistakes. So our A value is 1, our B value is negative 2, our C value is 10. So let's plug in the b value right here and here. Plug in the a value of 1 down here and up here. Plug in the c value of 10 over here. And now we're going to simplify with the discriminant first. So inside the square root, what's negative 2 squared? So the negative 2 squared is 4. So we really have 4 take away 4 times 1 times 10. That's 40. So you have 4 take away 40. I know I'm doing this work in my head. I apologize. What is 4 take away 40? Negative 36. We have a plus minus right in front of it. And we have a positive 2 out in the front. And it's all divided by 2. So the question is, what is the square root of negative 36? 6i. You guys remember that? 6i. So what we have here is 2 plus or minus 6i all divided by 2. So whenever you have addition or subtraction between two terms in the numerator, all divided by a single value or a monomial, you could split that monomial or that single value into each term and divide. So you could take this division of 2, put it on the 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So your answer would be 1 plus or minus 3i. Or you could reduce all by 2, and you'll get 1 plus or minus 3 with the I over 1, which is unnecessary. So 1 plus or minus 3i. So what's our correct answer going to be? Negative 2 and 1 plus or minus 3i. So that would be option C. These are fun. Write a polynomial function given those answers. So those are answers. So what I recommend, guys, is writing down the answer x equals negative 3. And then also writing down the answer x equals negative 5i. And the theorem that we learned yesterday, the complex conjugate theorem, says that if negative 5i is an answer, there's also another answer. What's the other answer? Positive 5i. So you're going to put also x equals positive 5i. Now, where did these answers come from? They came from a binomial that you ended up splitting up to solve, right? They came from a binomial so that you set equal to 0 after you split up to solve. So where did this answer negative 3 come from? It came from, and you could even show your work here by going plus 3 plus 3. That way you get the binomial x plus 3 and it's set equal to 0. So this is the binomial where the answer x equals negative 3 came from. Where did the other imaginary answer come from? Don't overthink it. Just put plus 5i to set it equal to 0. Plus 5i. You will have x plus 5i as the binomial that was set equal to 0 that gave you the answer negative 5i, right? And last but not least over here, same deal. Don't overthink it. Subtract 5i, subtract 5i, and then your binomial is x minus 5i that gave you the answer x equals 5i. Okay, so you really have your binomial that was set equal to 0, binomial that was set equal to 0, binomial that was set equal to 0. We're going to do that. Normally you would separate them to get this with the zero product property. Right now we're going to use zero product property backwards to put them all together. The x plus 3 times x plus 5i times x minus 5i. Now, always begin with your imaginary values, ladies and gentlemen. Why is that? Because these imaginary binomials are complex conjugates of each other, which means that they will eliminate the i's. The i's will disappear. Check it out. X times x, x squared. X times a negative 5i, that's going to be a negative 5i with an x. Positive 5i times x, it's going to be a positive 5i with an x. Positive 5i times negative 5i, a positive times a negative is a negative. 5 times 5 is 25, and I times I is I squared. So watch this magic. The negative 5ix with the positive 5ix completely disappear. They're opposite values when you combine them. And the I squared is really a negative 1, so you really have a negative 25 times a negative 1, which is really what? Positive 25. So you really have x squared plus 25 as a binomial. Instead of these two separate binomials with i's, you have one single quadratic binomial with no more i's. So we're not done yet. We still need to bring down the other binomial that we had over here, the x plus 3. and distribute there. X times x squared, that's x to the third. X times 25, that's 25x. 3 times x squared is 3x squared. 3 times 25 is 75. The only thing to do here is to rewrite it in order. X to the third plus 3x squared plus 25x plus 75. That's your final polynomial that gives you those answers. You could call it f of x, you could call it g of x. You could even set it equal to 0. If you did set that equal to 0 and solve, you would get the above three answers: -3, -5i, and +5i. This one's crazy because it has 3 answers, actually 4 answers, right? And by the way, they will be multiple choice answers. So, last one. So we really have, where did the x equals 1 come from? From x plus 1. Where did the x equals 4 come from? X minus 4, right? Okay. Where did the x equals 3i come from? X minus 3i. And we know that if 3i is a solution, so is negative 3i, right? So where did negative 3i come from? X plus 3i. So where should we begin? Distributing the red or the blue? Blue. Always start with the imaginaries. That way you get rid of the imaginaries. Okay. So we're going to distribute here. We have x times x. That's x squared. X times 3i. That's a positive 3i with an x. Negative 3i times x. That's a negative 3i with an x. Negative 3i times positive 3i. That's a negative 9i squared. Okay, the middle terms, positive 3ix, negative 3ix, cancel out. I squared is -1. So what we really have is the binomial, let me do it in blue so we don't get confused, x squared plus 9 again. Now we still need to multiply that x squared plus 9 with the x minus 4 and the x plus 1. Or we could multiply these guys first. Let's multiply those guys first. Let's see what happens. X times x, x squared. X times -4, -4x. 1 times x, 1x. 1 times -4 is -4. Combine the middle terms. You will get -3x with the -4 with the x squared out in the front. This is a quadratic trinomial that we still need to multiply by the blue binomial that we got over here is x squared plus 9. So let me rewrite this thing. So right here we distribute x squared times x squared is x to the 4th. X squared times -3x is -3x to the 3rd. X squared times -4 is -4x squared. Combine 9 times x squared, that's positive 9x squared. 9 times -3x is -27x. And 9 times -4 is -36. Out of all those terms, you could only combine the -4x combined with the positive 9x, and you'll get 5x. So your final answer is x to the 4th minus 3x to the 3rd plus 5x squared minus 27x minus 36, which is A? Yes, sir. It's A. It is A. By the way, tomorrow's test is not 14 questions. It's only going to be 12. That's good and bad news because, the less the amount of questions, if you miss one, your grade drops like 8%. So make sure you do this carefully.